real and synthetic data sets, I will only present the results with real data. We have used modulus bits. By modulus, I mean that n number, that large n, which is the product of primes, which again is similar to what you have in an RSA key. And let's see what we have obtained. In terms of parallel execution, the method, sequential method, is quite expensive indeed, especially for the exact NN method. But the speedup is really very good. So for instance, for the exact method, if we use a 768-bit key, the answer there is 1 second. It takes 1 second to process a query, which can be comparable to what would be done for a spatial counterpart of the query on the actual data, right, in plain text, without any PIR. This is the result obtained for using the data mining approach. So the empty elements, either dots or squares and triangles, correspond to the non-optimized run. The full points are optimized runs. So we can see that we can get as much as 50% savings, right, by employing this optimization. And if the data is static, then this can be a very good solution. By the way, all the experiments, including the parallel one, were run on standard hardware that you can find in a university. There was no special purpose machine. In practice, these operations can be very easily and efficiently implemented in a specialized machine with a very long word, for instance, which can do multiplications, because we only need to do multiplications, a very specialized operation. And this can be done with an FPGA much faster, right? And finally, comparison with previous methods on spatial transformation. First of all, I would say that there is no comparison because the assumptions are completely different, right? So we do not need a centralized component. We do not need other users. We do not need a specification of the value of k. However, we still have something to compare with, right? Because we can compare the financial cost of the two methods. And I come back to what I was saying at the beginning of the talk. The financial cost can be measured by the number of results that are being returned. Both the methods return redundant results. Okay, we have seen that. How many redundant results? The blue and red lines are our methods. The exact method returns, in this particular scenario where we have 65,000 plus points of interest, returns around 15 points of interest. The approximate method is slightly worse, around 200. But look at how many redundant points the Hilbert-Klog method, which uses spatial generalization, is returning. And look at the population sizes. So the generalization, the spatial cloaking methods are as good as our worst method only for 64,000 users. And 64,000 subscribers might not be that easy. And furthermore, we have used k equals to 20, which is, I would say, a mild privacy constraint. Maybe I will not be very happy if I can be distinguished among 20 other users. Maybe I want to set k to 100. So this would increase a lot the number of disclosed points. So to conclude, we have a new method based on cryptography. We do not use any spatial transformation. And because of that, we have provable privacy guarantees. Why? Because nobody can stage any sort of attack based on, we have seen, data distribution, outliers, who knows what other heuristic, which some spatial cloaking methods may be vulnerable to. Of course, we still have the problem of cost. There is still room for improvement in terms of cost. We would like to have an even cheaper solution. And we would like to support more complex type of queries, not just nearest neighbors, right? This is also a very good direction for research. Okay, I will stop here if there are any questions. Thank you.
So, if anyone is interested in getting to know more on talking to Gabriel, he has an office in the CERIAS building across my office, nearby my office, the second floor. So, and you can find his email address in the department web. So, this technique is quite fascinating.